Okay, so I'm starting a new project here. I'm making a white solid inside my new project and adding Particle Playground plugin. I'm just going to switch off the Canon, so particles per second to nothing on the Canon. And I'm just going to start off by having a look at the grid controls. So under grid you actually get a regular arrangement of particles across the screen. So because I've got a 16 by 9 layout, I've made my particles across 32 particles down 18, which is a 16 by 9 kind of arrangement. So that gives me a nice square arrangement of particles on the screen. Set the width and height to the full screen. Now what I'm demonstrating is that if you actually play this, you'll see that it makes that number of particles every frame, and you very quickly get a huge number of particles, which you don't want. So it's a good idea to keyframe the particles across and particles down. So I'm actually keyframing it to 0 on the second frame, so that it only makes particles on the first frame. That makes it a lot more controllable. So let's have a look at that. So now you'll see I have a grid of particles, and as soon as I press play they all drop off the screen because gravity is on. So I don't want them to do that, so I'm going to switch off gravity by setting affects particles from to be affects particles from none. So now if I play, nothing happens because it only makes one particles for the first frame, and there's no gravity, so they don't move. So I'm setting the particle size a little bit bigger, particle radius to 5, and I'm setting the colour to white. And what we're actually going to do with this tutorial is look at what happens with the persistent property mapper and the ephemeral property mapper areas of the plugin. And to do anything with this, I actually need to have something to work as a map to drive those things. And to illustrate what's going on, I'm going to make a solid, and I made it white, but actually I should have made it grey, so I'm just changing the solid settings to make this an absolute mid-grey. That's 128, 128, 128. On top of that I'm going to make a white layer, and I'm going to mask off just a small area of that. So I've got a small white area on one side of the screen. I'm going to make a black layer and do the same on the other side of the screen. And now I need all these three things to actually be treated as a single image to use in the mapping, so I'm just going to pre-compose those three layers. In effect, I've got a grey image with a white rectangle and a black rectangle on top of it. Okay, I'm just going to rename these things so I know what is what. So the white solid layer is my particle layer, and the pre-comp layer is my map layer. Okay, and I'm going to open up the persistent property mapper area of the Particle Playground plugin and use that layer as the map. And I actually have to say what that is going to drive. So when I first set it as the map I'm using, it's not going to do anything until I actually tell it what properties of my particles I want that map to affect. Okay, so I've also switched off the visibility of the layer, so it doesn't get in the way of seeing the particles, obviously. Okay, so let's see what we can do with this. So you have to decide, you've got 3 channels in your layer, the red channel, green channel and blue channel, and you can use those 3 layers, or 3 channels of the image to drive different properties of the particles. So if I map the red, say, to scale, and the scale goes between 0 and 1 at the minute, change that. So if I map it to scale, wherever the amount of red is 0, it's going to give me the first number, the minimum number, which is 0.5, so particle size is scaled down by 0.5. Wherever it's maximum, it's going to give me the large number, so wherever it's white in the image, yeah, it's going to be scaled up to 2. And you see I've set the green now to map to opacity. And we'll just change the blue to map to angle, so you see that particles are rotated. And just to see what happens, these can be dynamic properties. So if I add X speed as the green channel property, you can see that where it's positive green is going to give you a speed of 10, where it's no green is going to give you a speed of -10, where there's mid grey it's not going to move. The difference here, instead of setting it to speed, I've set it to X force. So in those areas while the particle is in those areas, a constant force will be applied. Once I leave those areas, I carry on moving because although there's no more force being applied, they keep their momentum. Okay, so just play around with different settings of different properties. So as well as scale, you can have just the X scale or the Y scale. Okay, I'm going to switch all these properties off now because I want to actually look at what happens if we have a more interesting map. So if you want to have some kind of random effects, a good thing to use is the turbulent noise. I'm going to set the turbulent noise to be low complexity, high contrast, so it's very easy for you to look at the map and see that we've got black areas and white areas. Where it's black, it's going to have low minimum values, where it's white, it's going to have maximum values. So I'll rename this as noise map, and if we use that as our map, again I have to pre-compose this, so be careful about that. If you don't pre-compose, it will treat it just as a solid layer, whether you apply a property to it or not, whether you apply noise to it or not, I should say. So now we're using red mapped to the X-force, and you see that random particles are moving random different directions. If we do the same and apply the green to the Y-force, what you see is you get a very definite diagonal value, and this is because the green and the red both contain the same values. So if it's black, it's going to go up and to the left, and if it's white, it's going to go down and to the right. What would be nice is if we had different randomness in the green and the red channel. So I'm going to edit my noise composition so that as you can see right now, it's only containing red noise, which means that the green channel is just black. So the green is going to be always minimum, so it's going to move up. The red is moving left and right as before. So now if I actually add some green noise, and to do that I'm going to duplicate the red noise that we've got, and I need the green noise to be, so I'm tinting it to green. So you see I applied a tint effect to colour the noise. Okay, so now with green noise only, I'm getting random up and down movement, but the X is going to the left all the time because it's, there's no red in the value. So what I need to do is actually, instead of having the green obliterate the red, I need to add the two together. So I change the layer type to add. Now we have yellow noise because the red and green contain the same noise, but if we just simply offset one of the two, then they will not have the same noise pattern in the same place. So now we do get random movement all over the screen, rather than the diagonal movement we got when we had a grey noise. So we have one more channel, so we could also apply some noise into the blue channel and again make that different from the other two noise. So I will duplicate the green noise and again offset the noise so it's in a different place, and we'll see how we can apply a scale property to the blue noise. So Now, although it's not actually a 3D effect really, you get a kind of a nice 3D effect because all these different size squares look like they're nearer to us or further away. Okay, and just a slight diversion here. Rather than have all the particles leave the screen when they're travelling towards the edge of the screen, I'm going to use the wall settings in the particle playground. If you create a mask, you can use the boundary of the mask as a boundary for the particles. So I've created a mask around the edges of the frame, and under the wall settings told it that the boundary is that new mask, which I called wall mask. And now when the particles hit the edges of the image, they're going to bounce off that mask. So now obviously you don't always want it to do that, but it's a nice trick to use if you do want to keep the particles within the frame. Okay, so now one thing that's I don't quite like about our noise is that our noise is static, so that it will behave a little bit like hills and valleys where the particles will always start to run in the same places because those places are always black or white. If we actually animate the evolution of the noise, as you can see I'm doing here, and I'm going to use an expression to do this. I'm going to set it to be time multiplied by something, and we'll just test this to see how fast that's moving. That's moving quite slowly really, so I probably want to put in a bigger number than that. So I'll try time times 500 in the expression. So if you don't know how to put in an expression, you alternate click on the stopwatch to start an expression, and then just replace the highlighted text with whatever you want the expression to be. So this is much nicer. I got a nice fast noise there. So now we do the same thing we did before. You can duplicate the noise twice and tint to green and blue and offset each one. So then all three will be animating, all three colours will be animating differently. Okay, so there's my colour noise. We just test that a little bit. Okay, so with this kind of noise you're going to get a nice random movement that is not always constant. So it won't always be the case that a particle in a particular area of the screen will be going in a particular direction, in other words. So a particle can now change direction, or change speed, change scale, while being apparently in the same area. Okay, so I'm just going to change a few things. Rather than change the scale, I'm going to change the opacity of the particles. I'm going to add a few more. I'm going to double the number of particles in each direction, so I've got a lot more particles. And with the opacity being changed, you'll get some nice effects when the particles overlap each other. So this is a little bit like what was happening to the particles I created from the text in the title sequence of this video. Though instead of obviously generating particles from a grid, in that case the particles were generated from the shape of the text, which I'll probably tell you how to do in the next video if you haven't already figured that out. I'm going to improve this by blurring the particles a little bit, so we're going to get cloudy kind of particle shapes, and I'm going to apply colorama driven from the alpha, of the layer. So this is all in the same particle layer. So I've blurred the particles, applied colorama, changed the input phase to be driven by alpha. I'm going to change the output cycle to give me a range of colors based on the alpha of the layer. So when you look at this, you get some kind of nice swirling, clumping kind of, it's not quite like turbulent noise because it tends to clump together and break apart, which is what you saw the particles doing. So different settings of the colorama effect and different settings of the amount of blur and things like this are going to give you different results, obviously. So again, it will take a little while to preview these things. You're not seeing the amount of time. I've cut out the time taken to generate the RAM previews when I'm showing you these things. So if you're doing it yourself, you have to be prepared for the number of particles on the screen is going to affect how fast you can preview. Obviously, this kind of thing is nice if you put the particles again into background color. So we'll try this with a background color and some shadow and see what we get. I'm going to give my particles some transparent areas in the low area of the color range. You can see how that straight away looks a bit nicer. I'm going to just put a little bit of shadow on those to lift them from the background. Then let's see how that looks. It would be a nice effect to use for things like flying paint or stuff like that, liquid explosions. So for the second part of the tutorial, we're going to go back to using the Canon to generate the particles. And I want to look at some of the ways you make particles change over time. One of the problems that you have occasionally when you're using mapping with the property mappers in Particle Playground is if you have the property map the same size as your composition, sometimes at the very edges of the frame you'll get mistakes happening where there isn't a value at the very edge of the frame. So you'll get, if you're scaling everything, you'll suddenly find that at the edge of the frame the particles aren't scaled. So when you want to do something where you're going to have particles at the very edge of the frame, it's a good idea to make your map slightly larger than your composition size. So now I'm going to increase that. You can see that the size of my map is 100 pixels bigger than my composition. So I made a white solid, and for this I'm actually not going to add anything other to the map. It's just going to be a white solid map just to have something to drive things. What I'm going to do is I'm going to set the map red to be mapped to lifespan. I'm going to use the same value for both the minimum and maximum, and put 0.3, which will mean that the particles will last for 0.3 of a second. So I've set the Canon to generate particles, and you can see that after a third of a second I've done it. So try it at a sixth of a second, they will die 1/6 of a second. So you get a spray of particles that then die after less than a second. So a good way of generating like firework effects or things like this. I'm going to change the colour. Now where this becomes nice is if you combine the lifespan with things that vary over the age of the particle. I'm going to use an ephemeral property mapper for this. I'm going to use the same white solid to drive it, and I'm going to say we're going to map the, we'll map the red channel to scale. But what we've done is say we want to scale particles only older than a third of a second. So you see that after a third of a second the particles scale. If you then feather the age, they're going to start scaling at one end of the feather range and end scaling at the other end of the feather range. So just make the particles bigger so you can see this. So particles have a lifespan of 0.6. They are given older, younger than setting of 0.3, so halfway through the age, and a feathering of 0.6. So in other words, they will feather over the entire life of the particle. I think you have to think about that for a while, but that's what's going on. So I'm going to set the opacity also. So now they're scaling bigger but fading out. So you get this kind of cloudy effect when you do this. So a nice way to generate smoke and things like this is to actually increase the size of the particle but fade it out. So you can see a nice example of this now. So to make rising smoke, add gravity and have the gravity set to direct upwards rather than downwards. So to make this a bit easier to see, I'm going to increase the lifespan of the particle to 2 seconds. And you see a kind of a smoky effect. So we'll play around with the velocity of the particles and things like this, and you'll get obviously different effects. So if you think hard about it, you can actually combine a solid red channel with a green noisy channel and blue noisy channel to give you red controlling lifespan and green and blue controlling the X-force and the Y-force like we were doing before. You'll get some nice turbulent smoke by doing this. I'm not going to do it right now, but it was again similar to what was happening in the opening title video. Is that kind of technique where solid color controlling the lifespan and noisy color for the other two channels controlling some turbulence. So what I'm doing now is I'm going to animate the Canon position so you end up with a smoky trail. And if we increase the number of particles, the size of the particles, you can get a nice effect. So right now I'm just playing around with some of the settings to try and get a nice kind of a trail going. And again, if we use similar techniques to we did in the last example, if I blur and apply colorama to this, we can get some nice effects. So right now with a bit of blur it already looks much nicer. So again, if you add colorama driven by the alpha of the particles, I'm going to change the modify setting so there's no alpha modification. I'm going to change the palette preset to be the fire preset. You should get a nice fiery trail. And with the lifespan and the age feathering, you get the particles die out, you get a nice kind of particles dying at the edges of the flame. Okay, so I hope that that's been interesting, and I will continue this in the next tutorial.